Okay, now I am on page 177. Right? Now, the binomial theorem. Now this you'll have to know. Right? Oh my god. And this is a new marker. Oh my god. Okay. So, consider the following. A plus b to the power 2. Right? How you would do it, you will just multiply it like how you would. You say a plus b times a plus b. You will end up with an equation. Simple, right? Now, what happens to the instance where you have a plus b to the power 5? That's going to be a plus b times a plus b times a plus b times a plus b times a plus b, which becomes very complex to deal with, right? This becomes a very long process. A plus b to the power 100. That is practically impossible. How many pages you're going to sit and do and multiply, right? That doesn't make sense. So, and also they tell you why it is impossible to solve a plus b to the power half. How are you going to do that? You're going to say half times, so it doesn't work, right? So, the binomial theorem enables us to simplify or expand all examples stated above. Now, this is where you're going to hate me again, right? This is the binomial theorem. So your binomial theorem is this formula here. It's x plus h to the power n is equal to, so your first term is xn plus nx n to the minus 1 h plus n minus 1 2 factorial n to the minus 2 squared plus n
that should be given under this formula sheet.
They don't give it to you. Right? Plus so on, plus so on, plus so on. This looks complicated, but after examination and practice of it, it becomes easy. And yes, guys, it does become easy, right? So, okay, look at the formula first. So you're given this sequence, x plus h to the power n. So it's a series, right? So your first term is x plus n. So what you do, whatever x is, you take x to the power n. Plus your next term is n times x to the power n plus n minus 1 times h. Next term, you take n multiplied by n minus 1 over 2 factorial. Do you all understand what factorial means? No, it's not factorial. Okay, so okay, I'll do this on the side. So this exclamation mark basically indicates factorial. Now what is factorial? Example, if I give you 3 factorial, what they're basically doing is they are basically saying 3 times 2 times 1. Right? Okay, so this here will be 3 times 2 is 6 times 1 is 6. If I had to say 100 factorial, right? It will be 100 times 99 times 98 times 97, and so on and so on and so on and so on and so on, right? How would you do it? Take out your calculator. Right. Type 100. Right. Now what you're going to do, you're going to press shift. And you see above the button that has x to the power minus 1, you have x exclamation mark. Right? So shift and press that button. Do you see in your head? So you see you have a button that has x to the minus 1 button, right? Above that it has x like that. So shift that button, and you see the number you have as 100 and exclamation mark. Press equals to. So that's 100 factorial. Yeah, it's not going to go on. Right. But anyway, concept of it, right? If you put 3 factorial. Okay, enough for 3 factorial. 6, right? 5 factorial, same situation, so on, so on, so on. It's gonna just keep on going. 6 factorial, 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 6 factorial
How do you get 100 factorial?
No, 100 factorial, it becomes an error because of the amount of numbers that you end up with. Because remember, it's 100 times 99 times 98. I was a bit dramatic when I went with that. Try 10 factorial or something and see what number you get.
You do 50.
50
goes.
50 goes, just keep on going. But big numbers are coming.
Yeah, times 10 to the 64.
Yeah, so it's very big numbers, right? The 10 to the 64 is
18 doesn't work.
right? So it's too big to fit in the calculator, right? And put the 6. So that's the basis of what a factorial is. Okay? Right. Any other things that you're looking to? No. Okay, so that's it, right? So let's do an example. So an example is develop the following with the binomial theorem. Okay? So I take this out. They got it there in the textbook, right? You can highlight it. The meaning of 2 exclamation mark is 2 times 1. We really have 2 factorial. Okay? So you can highlight that there.
Highest is 69.
And then after it goes away. But remember, you know what they basically get? It's 69 terms that they're looking at. So actually that's 68. Yeah, so you can carry on with it before it
No, the answer is times 10 to the 98.
and then after it's gonna
Probably 10 to the 100.
yeah.
Okay,
Okay,
that's fine.
so let's do examples, right? I'm gonna do this 5 examples video, but then you should understand the concept of it. So they want to know x plus 2 squared. Right? Now, in general, we would have just basically done x plus 2 times x plus 2. Because it's small. But let's do it using binomial theorem, right? So, looking at this and looking at this, you can tell that your x is equal to x, right? Your h is equal to 2. And your n is equal to 2. So now using binomial theorem, this would now become x squared, right? Plus 2x to the power 2 minus 1 times 2. Right? Okay? Plus 2 into 2 minus 1 all over 2 factorial x to the power 2 minus 2 h squared. 2 squared. Right. Okay, I'm not going to do any more terms because there's only it's to the power n to the power 2. You can see why, right? So, x squared is what? X squared plus it'll be 2x to the power 2 minus 1 is going to be 2x. And then multiplied by 2 is going to be 4x. Understand? Okay. Here, 2 into 2 minus 1. 2 minus 1 is 1 times 2. Now factorial is 2 times 1. So it's 2 over 2, which is 1, right? Fine. X to the power 2 minus 2 is what? 0. X to the power 0 is 1. So you're only left with this last term, which is 4. Right? If you carried on way further than that, right? What you're going to end up with is you're going to end up with, right? You're going to end up with 2 into 2 minus 1, 2 minus 2. What's going to happen here? 0. This whole portion is going to come 0. 0 multiplied by anything else over there is going to be 0. So you're not going to get any term past that point. Right? So this one would end like that because of the amount of series we're looking at your n value. Okay?
Only 2.
Yeah, so you'll only stop with, well, 2 terms, plus 3 terms in this instance. So that's how you would have used binomial theorem to solve for that. Okay? It's the same thing as if we said x plus 2 times x plus 2. It would came to the same answer. But I'm using binomial theorem to solve it, you'll understand what I did. All I did was I took the formula and I substituted it there. Right. Let's do another example. Next example is x plus h to the power 6 to 4 terms. Okay, now one term, this will be one term. This would be your second term. First term, second term, third term, fourth term. But remember, it does go on, right? Now, they'll never ask you to test more than 4 terms. So in your exam or something, if they give you an equation and tell you use binomial theorem to solve this, they will only ask you for up to 4 terms. They won't ask you for anything further. So you'll need to remember the formula basically from here till then, right? Up to 4 terms. If you go onwards, you'll notice a pattern of how you will do it. The term after this would have been n into n minus 1, n minus 2, n minus 3, all over 4 factorial, x to the power n plus 4, h to the power 4, and so on and so on and so on and so on. It keeps on going again, right? Okay, so in this one here, what is your x term? X, right? Your h term and your n term. So let's use binomial theorem to basically evaluate this for 4 terms. So you'll start off with x to the power 6 plus 6x to the power n 6 minus 1 h plus 6 into 6 minus 1 all over 2 factorial x to the power 6 minus 2 h to the power 2 plus 6 to the 6 into 6 minus 1 6 minus 2 all over 3 factorial. Right? Remember, this here is 2 times 1, this is 3 times 2 times 1, and then x to the power 6 plus 3 h to the power 3, and then so. But they only asked you for 4 terms, right? Then you need to simplify this. So far guys, are we okay? It's just a formula. What they showed you, you're just substituting into it. But I feel like you're gonna ask something.
Okay, so if you take that equation out to about 6, so you should have had 7 terms, right?
Yeah, because of the
Now 7 terms would be a great answer.
a whole answer. But the only one for remember 6 is a lot
So it's just like that decimal points. So so we'll basically rounding it off to answer.
you can say it. But because remember this was a very small number to work with, it's simpler. As they said earlier, if you have to the power 100 or if you have a fraction and stuff, it's difficult to work it out, right? Okay. Now this would be x to the power 6, right? This would be plus 6x to the power 5 h should have said, right? Plus what is this?
Step 2.
Okay, so 6 minus 1 is times 6.
That's it.
Okay, this is 1, 2, 3, 4, right? So this would be,
That's
yeah, 6 minus 1 is 5 times 6 is 13 all over 2, which is 15. So this will be 15 x to the power 4 h squared plus, then you'd say here, this would be 30 times 4, which is 120. 120 divided by 6, 20. 20 x to the power 9, no, this is supposed to be minus.
Number 1 would be plus the 1.
Yeah, here would be supposed to be minus 9. Right? Okay. This would be 3 and then h cubed. And that would be the simplified form of this using binomial theorem. Remember it would, yeah.
So 2 factorial is 2 times 1 and
3 factorial is 3 times 2 times 1. 4 factorial is 4 times. It's all the numbers going back down to 1. Okay, so yeah, that's basically. But I just showed you this here, but you can put it in your calculator.
So in this case, you wouldn't go to the fourth one because it would be 0.
No, you wouldn't go to the 6th, the 7th term because it will be.
Oh, it's it. Oh, this, but then this asked you.
They only asked you up until 4 terms.
Yeah.
So this is 1 term,
Yeah.
2, 3, 4.
Oh, okay.
Okay?
Yeah.
So, yeah.
8 term 0.
Okay.
You get 1 extra.
Yeah, it's always 1. And you notice a pattern, like you see how they go from x to the power 6, then it's x to the power 5, x to the power 4, x to the power 3. You would have went up until you ended up with x to the power 0. So that's how many times you do. So it would be 6, 5, 4, 3, 2, 1, 0. 0 would have gave you a constant number. That would have been the whole formula. So if you had any value for x and h, you just substitute it and you can solve it. Okay? That's binomial here. So far, not difficult. It's just this is a very long formula, but it's not.
And that one is what you can see, right?
I never saw it in the data sheet before. And remember, I need to print a data sheet for you, so you can see what you have there. Okay, so far we're okay. Okay. Then let's do. Right? Remember we said. So this is also to 4 terms, right? It becomes difficult to work out a bracket when it's x plus h to the power half. How are you going to do that? You can't say x to the power plus h to the power half times x plus h to the power half. You use this formula here. So in this instance here, your x value is equal to x. Your h value is equal to h. Your n value is now equal to a half. So now we're doing 4 terms, so it's everything. And from syllabus guys, once again, they're only gonna ask you for 4 terms. If they do test it, they'll ask you for up to 4 terms. Okay? So following our formula, this will be x to the power half plus half x to the power half minus 1 h, right? Plus half into half minus 1 all over 2 factorial. X to the power half minus 2 h2, right? Plus, this will be a half into half minus 1 half minus 2 3 factorial. X to the power half minus 3 h to the power 3. Right? You see, as you do it more, you'll get the hang of it and remember how you need to keep on putting in numbers where you need to put it. Right? And as you do it more, you'll remember your own pattern to it. How you'll never remember it, but as long as you'll remember it exactly, they get a map. Okay? So this will now become x to the power half plus half x to the power negative half h plus half minus half minus 1 is negative half, right? Times negative times half is negative quarter. Negative quarter over 2.
No. 1.
Half, right? It's going to become negative half. You can put it in the calculator if you can practice factorial. Put it exactly like how I got it here.
After half is quarter over 2 is half.
Can you make it half? You are right. 100% correct. So I did something wrong. Okay. B is negative 1 over 8. Why it's negative 1 over 8? If you have half into half minus 1 all over 2 times 1, right? Half, it will be half into minus half all over 2, right? And then this will be minus a quarter all over 2. remember this is the same as saying 2 over 1. So this would be minus quarter multiplied by 1 over 2, which would be,
0.8. Yeah.
right? But you'll just put it in the calculator, don't worry, okay? So, right. So, this would be x to the power negative 3 over 2 because it's negative 1.5. Okay? H squared plus there. Put it in the calculator, I'm not okay on this. What time you want me to work it out?
No,
I'm going to prove a point here. You see?
no, I'm just laughing because you don't want to make the same mistake.
Yeah. Because you see, Bilal will watch a video, then he'll come the next day, then he'll say, "Hey, so much mistakes you're making in there." Positive.
Yeah.
1 over 16, x to the power right now, negative 5 over 2. That's your answer for this term. That's right, isn't it? Negative 5 over 2.
Yes.
Yeah, up until 40. It's not bad, right? Whatever they give you, provided that you remember that equation correctly, it's just substituting.
Yeah.
Right? Not bad. Let's do another one. Now, I'll tell you how to do this.
Holy shit.
Okay. So would you actually say x
So
plus
you got
3
one,
into
you got 1
1/3?
So there's only 2.
We take out
Into
2
one.
of 3.
Now, so what you do, remember, understand with the roots, right? The square root, this is to 2, right? So the square root of 4 is actually 4 to the power half. So if I say cube root of x, it will be x to the power 1 over 3. You understand?
Yeah.
Okay, so this here is now 1 all over x plus 3y to the power 1 over 3. But if it's over a fraction, it's basically like an inverse, right?
Yeah.
So this is actually x plus 3y to the power negative 1 over 3.
Yeah.
Understand?
Okay.
Because remember, like if I gave you all x to the power negative 2, it's the same as saying 1 over x squared. Yes?
Yeah.
So that's the same thing I did there. Right? I had 1 over that fraction and then I basically made it 1 minus.
minus sign there.
Wait, this is
Yeah.
not a minus sign.
Understand.
Yeah, what is that thing? Yeah.
Right? It was just my finger. Okay, so guys, you understand how I got there? Right. Now, doesn't this look like something we work with? Right? So, your x value is equal to x. Your h value is equal to 3y, right? Your n value is equal to? Understand? No way anybody's confused? Now we fine? Okay. So, this here would be using this here now. X to the power n is x to the power negative 1 over 3 plus negative 1 over 3 into, even I forget it together, into x minus 1 over 3 minus 1 h
3y.
plus
The h is
Oh,
3y.
H is the H is 3y.
the h is 3y. Shit. Right? Okay. Even substituting sometimes difficult, huh? Right, plus, then you're going to end up with negative 1 over 3 into negative 1 over 3 minus 1 to factorial, right? Okay. Then you're going to end up with x to the power negative 1 over 3 minus 2 3y to the power 2 plus n again is negative 1 over 3 negative 1 over 3 minus 1 negative 1 over 3 minus 2 all over 3 factorial x to the power negative 1 over 3 minus 3 and then it's going to be, I've got no space to write this, right? 3y cubed. Right? I know it's a long one, but it's just basically
No, -3, yeah.
where?
The one third corner. That's
Yeah.
yeah.
No. It's just h to the power 3. H is 3y.
Oh, x.
X.
Yeah.
One third.
Oh, yeah.
Yeah.
Right.
Yeah.
The first term would be x to the power minus 1 over 3 plus. So, what is this term? Minus 1 over 3, right? You remember this is also a constant, so you just multiply those two parts in terms of simplifying it, right? So, this would just become what? Minus 1. You'll understand it, right? So, it will be minus 1, so it will be minus x to the power minus 1 over 3 minus 1 minus 4 over 3.
Yeah.
1 and 1 third, right? So it will be minus 4 over 3 y. Understand? Because remember it would have been minus 1 over 3 x to the power minus 4 over 3 times 3y. But that constants you can multiply it, okay? Right. Plus, what is this whole term? So this would be, okay, I'm going to show you the full thing, right? 2 over 9, and then the x to the power minus 1 over 3 minus 2, 7 over 3.
Minus 7
7
over
over
3.
3, and then 3y squared is going to be 9y squared, right? But then this 9 times that, it will be left with 2.
2, yeah.
Okay, right? Okay, so this here is actually 2y squared. Fine? Can I say that? Is it okay? Wait, right. So I covered that term, covered that term, covered that term. Now we are right? So this whole thing in the calculator, what you
Minus 14 over 18.
14 over,
18.
and then here you're going to end up with 10 over 3. So 4 minus 10 over 3. And then here you're going to end up with 27 y cubed. Right?
No.
81.
That y only, the bracket should be on the y only. Y is
14 over 18.
Yeah.
81, yeah.
And then 3 cubed is actually 81, not 23. No, it is 27.
27, yeah.
Yeah, but
This is
yeah,
fine.
but the way you wrote it is wrong.
Sorry, Chandra.
Yeah.
But that, and And remember this constant can get multiplied to that.
27, right?
No, I'm gonna love it now. 14 over 81 times 27.
81 is 3, 14 over 3.
27.
14 over 3.
14 over 3.
And then this will be 4 times. That part is not there because in the paper you would have done calculator work, right? So that won't be the bad part or difficult part, but the concept of what I did, do you understand?
But you could be get it wrong if you substitute. Yeah. Gotta be accurate.
Yeah, you have to be
That's very accurate.
Okay, let's do one more.
What are you gonna do?
I'm gonna do one more. Now they tell you this, right? They tell you to use binomial theorem to solve for x plus h plus 1 to the power 9 in powers of x plus 1 to 4 terms. So the to the 4 terms we understand, right? We're using this to 4 terms. What do they mean by to the power in powers of x plus 1? What they basically referring to is you just need to rearrange this into x plus 1 plus h to the power 9. So your x term will become x plus 1. Do you understand? Because they want it in powers of x plus 1. So when they ask you in powers of that x term, they want the x term like that. And it will always match something over here. You just need to rearrange it to make it look like that.
Oh.
So now when you make it look like this, what is your x? So your x here will be equal to x plus 1. Your h will be equal to h. Your n will be equal to 9. Before I carry on, does everybody understand this? Is anybody confused?
Okay, so you just rearrange
Because they want it in powers of x plus 1. They'll ask you exactly like that. Okay, so far we fine? Good. Right? Now it's just basically using that whole thing. Right? Your x in this instance is now x plus 1 to the power 9 plus, then it will be 9 x to the power 9 minus 1. No,
No, x times 1.
it will be 9 into x plus 1 to the power 9 minus 1 h, right? Then it will be 9 into 9 minus 1 all over 2 factorial times x plus 1 to the power 9 minus 2 h squared, right? Based on the formula. Then it will be 9 into 9 minus 1, 9 minus 2, 3 factorial x plus 1 to the power 9 minus 3 h cubed. Right, so far you see we did 5 examples, you're already remembering most of the formula. So you keep on doing more examples, it will stay in there after. Like how you remember theorem of Pythagoras. Same thing. Okay? Whew. Right. How would you write on your final answer? Don't worry guys. You don't need to work this out. X plus 1 times x plus 1 does x. You don't have to do that, right? You just need to write it out as x plus 1 to the power 9. That's your first term. Right? Here would be plus 9 x plus 1 to the power 8 times h. If you had a value of h, you would have just multiplied it to the 9. Like how we did here. We had a value of h when we squared it and then we multiplied it to the first term. Right? Keep your numbers, your constants together. Plus 9 minus 1 is 8. 9 times 8 is 72 over 2.
36. Yeah, 36.
36. 36 into x plus 1 to the power 8 h squared. right? Plus. Okay, this top part will be 72 again. 72 times 7. Now check for the whole thing here, calculation. So the whole thing with this bottom part.
Eighty-four.
84. So this would be 84 x plus 1 to the power 6 h cubed. And that there is using binomial binomial theorem to solve for x plus h plus 1 to the power 9 in powers of x plus 1 to 4 terms. Okay. Any questions?
You said the x plus h plus 9 to the power 9 is equal to x plus 1 plus h to the power 9.
Yeah, why by
I got it.
So you see when they ask in powers of x plus 1,
Mm.
they want the value of x when you're substituting in binomial theorem to be x plus 1. So that's why I rearrange the formula to get x plus 1 plus h to the power 9.
Okay.
And if you look at the second line, well the first equals to part, that way I wrote it out is like how I got x plus h to the power n there. That's how I'm able to get x equal to x plus 1, h equal to h, n equal to 9. And then after this, just put it in the formula. Okay. So yeah, guys, I just need to maybe try to remember a way to remember the formula, but it's only up to 4 terms, so if you figure out a pattern, to be honest, I don't have any good pattern of it, I just try to picture it. But yeah, maybe when you go in the paper, just write it down. So you have it. Okay, that was binomial theorem. What's wrong?
So that second step on that last example, you didn't have to put the bracket between that x plus 1 and h. You could have just said x plus 1 plus h. Is that
Yeah. I just grouped it to show you which would be the x term.
okay?
You'll see in exercise 6.2, they got a lot of examples on it again. And you see towards 12 and question 13 and 14, they got in powers of x minus 2, in powers of x minus 3. It's all. So basically what they're doing is they're solving for the whole bracket, but it's generally to larger powers or powers that are not normal when you are working it out, like to the half or to a negative 1/3 or something like that. Right? That's why we would use binomial theorem. And you see binomial theorem also comes into play in differentiation. Okay. Yeah, that's it for maths today. Today you learnt about the limit by limits, the concept of what a limit is. You learnt about the different theorems to limits. You learnt about the limits in the form of 0 over 0. How would you do that? 0 over 0, you factorize to get rid of the terms that give you 0. Then you learnt about limits in the form of infinity over infinity. And what you do then? The highest power is in the denominator. Conditions. If you have the same highest power in the numerator and denominator, what will be your answer? The coefficient of the highest powers. Right? If you have a higher power that is in the numerator, what will be your answer? It will move towards infinity. Remember that arrow towards infinity is important. That's the answer. Arrow towards infinity. You're saying that striving or moving towards infinity. And if your highest power is in the denominator, your answer would be 0. Because you're going to end up dividing by by infinity. And we said if you're dividing by infinity, your answer would be 0. Cool. Okay. It will come. You'll do more examples, do practice, it will come. Tomorrow we're going to start differentiation